Okay, we're going to do a little review on some of the foundational skills that we will use in Math 7. So we're going to be doing like a I do, you do review. So the top two problems we'll do together, and then I'll have you do the next two on your own. So if we're going to write a number in scientific notation, remember really, really large numbers get positive exponents. Whereas if we have really small decimals, we're going to use a negative exponent. Okay, so that's really important to remember because if we're doing something times 10 times 10 times 10, that's going to be a big number, but times 1 over 10 times 10, that would be a small decimal. So let's take a look at this first one. We have 8,001,100. I know in scientific notation I need one number in front of the decimal. So I know that my decimal is going to stop between the 8 and the 1. When it's not written, it's at the back, and then we count how many times it takes to move from the back to that line. So it takes 1, 2, 3, 4, 5, 6 times, and make sure you're doing this on your page too. So that would give me 8 point, the decimal is now there, 1 times 10 to the positive 6. It is going to be a positive 6 again because it is that large number. 8,100,000 is a large number. It's not a decimal, so we use the positive exponent. Let's look at the second one, 0.00023. The decimal needs to go in between the 2 and the 3 so that there's one number in front of it. So 2 would be one number in front of the decimal. So my coefficient would be 2.3. Now let's see how many times it takes to get in between those two numbers. Once, twice, 3 times, 4 times to get in between. So it's always times 10. The base is always times 10. And we said 1, 2, 3, 4 times. Now, it is going to be a negative 4 because that number is a decimal. So we need to use negative numbers. And moving on to the next one, 6.77 times 10 to the 4th. This is already written in scientific notation. So we're just going to move the decimal the number of times the exponent says. In this case, we want to make that number a bigger number because it's a positive exponent. So we're going to move our decimal once, twice, 3 times, 4 times. In those little holes, we fill in our zeros. And then I can rewrite the number, and I know it's 67700. The next one is a negative exponent. So as soon as I see that negative exponent, I know I want to make it into a decimal. So I'm going to write this a little bit further over, the coefficient, 8107. And I need to move the decimal 6 times to the left because that is the way I can make it into a decimal, not a bigger number. So 1, 2, 3, 4, 5, 6. Draw your new decimal, write your 0, and then fill in all your zeros. 2, 3, 4. We should have 5 zeros in front of the 8, not including the 1 in front of the decimal. All right, if you want to go ahead and pause the video and try this section underneath right here on scientific notation, you certainly can do that. Okay, so this next part is converting fractions to decimals. When we convert fractions to decimals, we have to divide the numerator by the denominator. The numerator, remember, is that top number. That's the one that goes in the house. So if I'm doing 1/4, I'm going to say, okay, well, I'm going to make a little house out of, or a little L out of this, and which number's in the house? The 1. So I need to do 1 divided by 4. Okay, so then I'm going to ask myself, can 4 go into 1? Well, no. So I have to add the 0 and the 0 and a decimal. So can 4 go into 10? Well, yeah, 4 times 1 is 2, and 4 times 2 is 8, and 4 times 3 is 12, so I can't go over 10, so I'm going to say, okay, yes, it goes into it 2 times. Then I multiply. 2 times 4 would give me 8, and I'm going to subtract. 10 minus 8 is 2. From here, I need to bring down a 0 because 4 cannot go into 2. So every time it cannot go into something, we have the ability to bring down a 0. How many times can 4 go into 20? 5 times. 5 times 4, is 20. So then I would have nothing left, okay? So 1/4 is 0.25. Let's try 2/3. So 2/3, 2 is gonna go in the house, 3 is gonna go outside of the house. How many times can 3 go into 2? 0. Add the decimal and the extra 0. How many times can 3 go into 20? Well, you have to go through your 3's. 3, 6, 9, 12, 15, 18, 21. So I don't want to go over 20, so not 21. That's 3 times 7. So 3 times 6 will get me as close as I can get. So then 6 times 3, we get 18. And we subtract. 20 minus 18 is 2. Bring down a 0. 3 can go to 20 again, 6 times. So you see here, 2/3 is 6 repeating. And finally, 4/5. So 5 can't go into 4. We add the 0. How many times can 5 go into 40? 5, 10, 15, 20, 25, 30, 35, 40. That is 8 times. 8 times 5 is 40. That was a nice and simple one. We subtract and we get a remainder of 0. Now, if we're converting the decimal to a percent, then we move the decimal 2 times to the right. So let's take a look at the one we just did. So 0.25, move the decimal once, twice, and that equals 25%. Now, with the 0.66 is a little bit different, so go ahead and write 0.666 on your page. And then obviously that would continue on. If we move that decimal over 2 times, 1, 2, it ends up being 66 in front, but then 0.6 repeating percent. You want to make sure you have that final answer at the last part. All right, so now you can go ahead and do the section below this, convert these fractions, and once you have these 2 sections done, just raise your hand and we will come and check. So go ahead and pause the video. All right, so our powers of 10, that just means we're multiplying 10 by an exponent. So here we have our exponential form, 10 to the second, 10 to the first, 10 to the negative 1, 10 to the negative 2, and 10 to the negative 3. Then we have our expanded form, and then what it actually equals. So 10 to the 2 in expanded form is 10 times 10. We're multiplying this number by itself 1 time, or 2 times. 10 to the first would just be, okay, we're just multiplying 10, which is still equal to 10. 10 to the third up here would have been 10 times 10 times 10, which is 1,000. 10 to the negative 1. Once we get to negatives, it doesn't make the number negative. It means we switch it over to be a positive exponent. Okay, so just be 1 over 10 to the first, not negative first, which, if I wrote that as a decimal, is 0.1. I remember that because I start with a 1.0 and I move the decimal 1 time, just like scientific notation. Okay, then I have 10 to the negative 2, so that's technically, as a fraction, 1 over 10 squared. So 1 over 10 squared, that's written a little bit better, or you might write it, oops, one over 10 times 10, which would be 1 over 1,000. This one would be 0.01. Each time we're adding that 0, or again, you can start at the 1, and you can move your decimal 2 times, and you have to fill in the 0. Okay, 1 over 10 to the negative 3 would be 1 over 10 to the third, which would be, bear with me, 1 over 10 times 10 times 10. And in standard form, that would be, okay, we're going to start with the 1. We're going to move it once, twice, 3 times. 0.001, right? Go ahead and pause the video and work on the part underneath it. All right, so equations. You guys are probably pretty good with these, but I thought we'd review the basics. So when I look at this equation, x minus 8 equals 12, I'm looking at really what x and the constant are doing. So if there's no number in front of the x, then we can go straight to the constant. Actually, we always go straight to the constant. So instead of a -8, we need to both sides figure out what's going to get 0. What's the opposite of -8? The opposite of -8 is your +8. And that's how I'm going to get 0. -8 plus 8. But if I do it to one side, I've got to do it to the other. So then I actually calculate 12 plus 8, which would be 20. And x is left over by itself. The next one, x plus 7 equals 23. I'm going to draw the line showing that what I do to one side, I have to do to the other. And we're going to say, okay, well, x and 7 are adding, so the opposite of adding would be to subtract. So 7 minus 7 is 0. 23 minus 7 would give me 16. All right, your next problem, x divided by 6 equals 7. To both sides, we're going to multiply by 6. This would cancel out, and we're left with x equals 42. The reason we're multiplying is because x and 6 were dividing. Multiplying is the opposite of dividing. Okay, and your next one, we're going to divide because -5 and x, when they're right next to each other, are multiplying. So the opposite would be to divide. Because -5 divided by -5 would cancel out and give me 1. If we do it to one side, we've got to do to the other. So 75 divided by -5 is going to give me -15. So x in this case would be -15. Okay, go ahead and pause the video and work on the next section on equations right below. Okay, after you've gotten this check, we're going to go to the inequalities. So the inequality symbols, as a refresher, you've got your less than symbol, your greater than symbol, your less than or equal to, because it has the line underneath it, and your greater than or equal to. Okay, remember, less than and greater than are open circles. Less than would go this way, greater than would go this way, and less than or equal to would be open. And greater than or equal to. Okay, so those are our signs we're going to use when we graph. Now when we solve inequalities for x so that we can graph them, we solve them just like equations. So x minus 8, if we pretend like there's an equal sign there, what's the opposite of a -8? Again, a +8. So to both sides, we'd be adding 8. We'd get x, we'd bring down our sign, and we'd have 20. Okay, now this one is a little bit different. -2 and x are multiplying, so the opposite of that would be to divide by -2. When I divide by -2 on both sides, these cancel out. I have x left over, but I have to flip my inequality symbol because I divided by negatives on both sides. This also would happen if you multiply by negatives on both sides. So then 14 divided by -2 would give me -7. Okay, go ahead and pause the video and you can work on the next two problems, next two parts. And the last section of this is tax, tip, and discount problems. We always set them up this way: percent over 100, your tax or your tip or your discount, the X usually, over the original price. So as a reminder, if the question asks for tax, tip, or discount, we don't add. It's just X. If the question asks for the total after tax or tip, we add. And if the question asks for the sale price, we have to subtract. So those are some key words to keep in mind. So tax, tip, and discount, we don't do anything. Total and sale price. I think total looks like a T, so does adding. Sale price is an S, subtract is with an S, okay? So go ahead and solve those tax, tip, and discount problems below, and then at the bottom there's one more translation for you to do. Awesome job.